All right, so this is Slant Asymptotes, day 2 of 2.6. We're on page 25, and we're going to determine slant asymptotes. We already looked at two types of asymptotes. You had vertical asymptotes, you had horizontal asymptotes. A slant asymptote, when we look at the graph, will look something like this. It'll be just a slanted line, and maybe a vertical line, and your graph will usually fall in between these kind of regions here. It gets close to the asymptotes without crossing. So that's just one example of a slant asymptote, and that's basically the shape of the graphs that we're going to end up looking at. So how do you find the equation that slant asymptote? So what you need to do to find that slant asymptote is we're going to do some long division. So actually I'm going to change these two problems slightly here. So for 2a, we're going to make this one, let's make this x squared in the top and just plain old x in the bottom. So x squared divided by x minus 9. I'm just going to try and keep the numbers a little bit easier for you. So to find the slant asymptotes, we're going to do long division. So we're going to go through and divide. And actually the problems that you have, you'll be able to use synthetic division. So we use synthetic division. We'll divide that equation, and then we're going to delete the remainder. The reason why we delete the remainder is the remainder actually gets really close to 0 very quickly, so we can just kind of ignore it. So this is my function, x squared over x minus 9, because we changed the problem, not that anything divided. And we're going to do synthetic division. So synthetic division, that's where you set that bottom equal to 0, and you solve. So you get x is 9. 9 was the number that goes in the box. And then the numbers across the top row are all of the coefficients of that numerator, going from, in this case, x squared, all the way down to your constant terms. I have 1x squared, I have 0 x's, and I have 0 constant terms. So I have to put those placeholders in there. And then just like we did before, you bring the first term down, bring the 1 down. You're going to multiply 1 times 9, and we get 9, goes in the next column. Add down, we get 9. Multiply 9 times 9, we get 81. Add down, and you get 81 for that last column. Remember, this is the remainder. And we said in the directions there, we're going to delete that remainder because that remainder is going to get real close to 0. So I started with x squared, which means these are the coefficients for x to the first and your constant term. So that's what the division looks like. Now we're going to write it as the equation line. So it's going to be y equals x plus 9. So this is my slant asymptote. And it's the equation in the line. That's why it's y equals and not something else there. So y equals x plus 9. Now if I have to go through and graph that, you don't have to write this part down, but if I'm going to graph that line, I have a y-intercept of 9, and I have a slope of 1. So you're going to have a slanted line that looks something like that. Right? You'll have other things going on in the problem as well, but just for now, that's how you find the slant asymptote. Just divide, top divided by bottom, and then simplify. Letter B, I'm going to change this problem as well because I want to make sure that there's something that we can use synthetic division for. So this one, let's change this. The top can stay the same. Let's make the bottom just x plus 2. So we'll just change that bottom. Instead of 2x was 4, we'll just make it x plus 2. So if you set the bottom equal to 0, we're going to get x equals negative 2. Remember, that's the number that goes in the box. Okay, and then the numbers across the top row, get this a little thicker. The numbers across the top row are these coefficients up here for your polynomials. So 1x squared, we have 4 x's, and we have negative 6 for the constant term. Bring the first term down, multiply, add down, we get 2. Multiply, add down, we get negative 10. Again, that's the remainder. So we're going to ignore that. These are the coefficients then for, I started with x squared, so it's going to be 1 degree smaller. So x to the first and plus 2. So this is my slant asymptote for this problem. So you're just going to divide, do your long division, And it's always going to be the equation of the line. It's always going to be y equals something with an x, and you might have a constant term, or the constant term could be 0. So that's what we're going to look at. And then we're going to put it all together, and we're going to do some graphs with it. So down here, what do you need to graph? If you can simplify the equation, we'll simplify the equation first. All right, so if you can factor and do any canceling, that's good. Horizontal, vertical asymptotes, holes, just like we did before. That was yesterday. And we'll put them on the graph. What are the slant asymptotes? That's what we just looked at. So if do your long division and then delete the remainder. What's the y-intercept? So you can find the y-intercept by letting x equal 0. Find the x-intercepts by letting y equal 0. We can look at the end behavior for the function. On the quiz, I'll just give you these limit statements. I'll give you a bunch of different limit statements, and you'll tell me what's going on with that. And then for each section, you just need a couple more points. You need 3 points in each section to go through and graph. And then just connect them all with the smooth curve. And like I said, you're using your graphing calculator, so look at the shape of the graph in your calculator first before you start working too hard. All right, so let's see. Let's try a couple examples here. So this equation looks good for number 2. We'll leave it this way. So in this problem, the first thing that you're going to do is you're going to look to see if you have any holes. And if you have holes, that means you can cancel a factor out. Well, nothing factored, nothing cancels, so there's no holes. So no factors canceled out. And then the next thing we can find is vertical asymptotes. So vertical asymptotes, we're going to set the bottom equal to 0, so x minus 2 equals 0. We'll get x equals 2. So that's my vertical asymptote. So over in the graph here, I'm going to just go ahead and graph that. So here's where x is 2. Okay. And then we'll come back there and we're looking for horizontal asymptote. So a horizontal asymptote, that's where we look for the ratio for the highest power for x. So x squared is the highest power of x. I have one of those in the top, I have 0 in the bottom. 1 divided by 0 is undefined, which means I have no horizontal asymptotes. All right, and then the final one would be the slant asymptotes. And to have a slant asymptote, the degree in the top will be 1 bigger than the degree in the bottom, which is what we have. So if you look at that slant asymptote, the number that goes in the box, if I set the bottom equal to 0, I get x equals 2. So that's what's going in my little box there. And then the coefficient. So I have 1x squared, I have 0 x's, and I have 0 for a constant term there. All right, so then we're going to go through and do our division. So bring the 1 down, multiply, and add down. Multiply, we'll get 4. Add down, we get 4 for the remainder. So we're going to forget about the remainder. And then these are the coefficients. Then we started with x squared. So this is going to be the coefficients for x to the first and a constant term. So that's my slant asymptote. So we're going to put that on the graph. So graphing the equation line, I have y-intercept of 2. There's 2, and I have a slope of 1. So up 1 to the right 1. So there's my, my 2 asymptotes. I don't have a horizontal asymptote. We need x and y intercepts. So let's go ahead and find x and y intercepts. Let's make this thinner. So x-intercept, that's where we let y equal 0. So x-intercept, y equals 0. So 0 equals x squared over x minus 2. If you put 0 over 1, we can cross multiply. We'll have x squared times 1 is x squared, and 0 times x minus 2 is just 0. So x equals 0. X equals 0 when y equals 0. It's just the origin. So I can plot that point on here. I don't know why it wants to be blue. Here we go. Now we're white again. So 0, 0. There's another point. And then we can find the y-intercept. If the x-intercept is at 0, 0, the y-intercept is going to be the same thing. So let x equals 0. So we would have y equals 0 squared over 0 minus 2. 0 divided by negative 2 is just 0. So when x was 0, y was 0, which is that same point there. All right, now at this point, we have all of the points that we need. We found all the asymptotes, the holes, all of that stuff. The only thing left then is to come up with a couple more points. Well, I have one point in this region that's on this sort of left side of the vertical asymptote. So let me pick a couple more numbers over here. Let's pick maybe -1 and +1. And that'll give me a couple more points in that sort of triangular region. And then I don't have any values above 2. So let me pick a few values there, like 3, 4, and 5. I'm just going to slide this over a little bit and pull up the calculator. Slide it just a little bit more. Here we go. So in y equals, I can clear out what I have in here. We're going to type in that numerator, x squared, divided by, now we need denominator, you have 2 terms, so it has to be in parentheses, x minus 2. And you can look at the graph of it. You can see what it's going to look like. There's sort of that bottom part. And that top part, it's cut off a little bit by the top of the graph there, but we could make the window go a little higher there and see more of it if we want. But really, I just need these values here for this table. So second and table. And then I can scroll here when x is -1, y is -0.3, right, that repeats, or -1/3. When x is 1, y is -1. When x is 3, y is 9. X is 4, y is 8. 5 is 8.3 that repeats. So that gives me a few points then, and I can plot those on my graph then. So let's see. So if we're at -1, we're at -0.3, which is right about there. At +1, I'm at -1. And then I also had that x and y intercept. So my graph is going to get close to that asymptote without crossing. I got pretty close on that side. And then let's plot these other values here. So x is 3, y is 9. It's going to be way up here. When x is 4, y is 8. Maybe about there. And when x is 5, y is 8.3. So it's kind of going like that for those 2 branches there. So that's what you're going to have to go through and do, is find those values there. X-intercepts, y-intercepts, and then the asymptotes and holes. And then just pick some values. All right, you can pause this if you still haven't copied all of this down. I'm going to clear this, and then we'll go on to the second example number 3 there. All right, so same process for this one. Doesn't look like we have anything that will cancel for the factors, so we have no holes in this graph. Vertical asymptotes, what's left in the bottom here, we'll set equal to 0 and solve, so we get x is -3 is my vertical asymptote. If I try to find horizontal asymptotes, highest power for x is x squared. I have 1 x squared in the top and 0 in the bottom, which is undefined. So I have no horizontals. Slant asymptote. So this is the long division. So the number in the box is -3. That's what makes that bottom equal to 0. I have 1 x squared in the top, -3 x's, and +4, just coming from here. First term comes down, multiply and add. Multiply, add down. Get a remainder of 22, so we're going to delete this. All right, and we started with squared, so this is going to be the equation y equals 1x minus 6. So this is my slant asymptote. All right, let's put these on the graph and put them all on there. So x is -3, is a vertical asymptote. And we have a slant asymptote at x minus 6. So negative 6 is my y-intercept. Slope is 1. Continue this down here, and I'm actually going to erase this vertical asymptote and write it somewhere else because I think my graph is going to end up in this part and in this part here, so I want to have a little space in there. So I'll stick it down here. VA x equals negative 3. All right, so we got those pieces. We need x-intercepts and y-intercepts. So we can work hard or we can work smart. So let's pull up the calculator. Let's put this in the calculator and kind of look at this and see if we can find the x and the y-intercepts looking at the graph. So my numerator has to be in parentheses because it's more than one term. And the denominator as well, so x plus 3. All right. So you can see a lot of that graph. Now there's going to be another branch down here in like quadrant 3, but I don't see it. So let's hit the window button. You can see from my graph here, it's going way below. So let's make y go lower than negative 10. Let's maybe go to negative 20 and see if we can see the graph. Oh, you can just see the very top of it. All right, so let's maybe change that, maybe go to negative 30, so we can really see the graph pretty well. All right, now we can kind of see those two branches. You kind of know what this shape is going to look like. Kind of looks like a weird, like sideways parabola kind of thing going on there. All right, so we have those on there. So we know the shape. We know it's going to go in this region, in this little triangle part, like right in here. We're going to have another piece up in here, but let's plot some points to come up with that. And then the other thing that we can look at is it looks like you're going to have a y-intercept up here. Crosses the y-axis. I don't think it's going to cross the x-axis. And we could look at the table of values and see what happens. Is there a place where y is equal to 0? And it doesn't look like there's ever a place where y equals 0. It gets really close to it, but doesn't actually equal it. And if you can't tell by looking at the graph, you can go back to the equation and you can plug in x-intercept, we let y equal 0. Let's see what we get. So we would have 0 equals x squared minus 3x plus 4 over x plus 3. If you put 0 over 1 and cross multiply, we'll have x squared minus 3x plus 4. And then cross multiply the other way, 0 times the x plus 3 will give you 0. And then the thing is, when you try to solve this, it doesn't factor. When you do quadratic formula, you end up with imaginary numbers. So a is 1, b is negative 3, c is 4. So x equals negative b, so positive 3, plus and minus negative 3 squared, so 9, minus 4 times a is 1 and c is 4. I can stop there because I have 9 minus 16. 9 minus 16 is going to give me the square root of negative 7. So it's imaginary, so there's no x-intercepts. No x-intercepts, there we go. So we're not going to have any x-intercepts for that. The y-intercept I could find by hand, or if I want, in your calculator, when x is 0, y is 1.3. So that's my y-intercept. So when x is 0, y is 1.3. And you can just round to that. It's 4/3 is the exact value. All right, so let me make a little bit of space here. This was just a little rough sketch, so we're going to get rid of that. Get rid of this little rough sketch here. And we'll plot some points here. All right, our y-intercept, I can plot that. That's at 0, 1/3. So when x is 0, y is, 1 and 1/3. I'm going to make it green so you can see the graph. There we go. All right, we don't have any x-intercepts. It's not going to touch the x-axis at all. So let's make a table of values. So I'm going to erase this piece about the intercepts. So if you don't have it copied down, pause the video right now. You can finish copying it and then start back up. There we go. All right, so then let's make a table of values. Let's pick some values for x, solve for y with the calculator. So I don't have any values in this region on the left side of -3. So let's pick like -6, -5, -4. That'll give me a few points in that region. In the other region, I already have this 1 point. So let's pick a couple more points. Let's pick maybe x is -1. And maybe x is +1. And like I said, with the graph and calculator, you already know what the shape of the graph is looking like. So you don't have to plot too many points there. All right, so let's put this in the calculator. We got it in there. Let's go to the table then. When x is -6, oops, I got to scroll up a little bit. We get -19.33, nice round number. When x is -5, we get -22. X is -4, we get -32. So it's pretty far down there, and that's why I had to change that window. All right, and then down here further, when x is -1, y is 4. When x is +1, y is 0.5. All right, so that gives us enough points to get a pretty good idea of what this graph is going to look like and where it pops back up. All right, so -6, we're at -19. Let me see, 1, 2, 3, 4, 5, 6. -6, we're at -19 point something. So it's going to be pretty far down here. At -5, we're at -22. So we're down even further there. Let's see. See, it's about -19. -5 is about -22, down a little further. And -4 is at -32, so it's even further down. So it's kind of looking like that. And then -1 is at +4. This one will be a little nicer. And +1 is at 0.5. So this graph getting close, oops, I missed that point. Getting close to the asymptotes without crossing. And really, I should stop just before I get to that x-axis there because we said it doesn't have any x-intercepts. Let's try and make that look a little bit. There we go. So it gets close. And that's all you need to do with those. There's not a lot that you have to go through and graph with these slant asymptotes. But to find them, it's the long division, delete the remainder. Okay, you can stop the video. The homework problems are on page 225. And you're doing 43 through 46, and you're going to graph just the first two. So ignore the directions there. You're just going to graph 43 and 44. You don't have to graph all of them. Okay, the other ones you'll just find the asymptotes and the holes for it. All right, that is it.